All right. So here we are at day three. Day three is incident response. So you start at samsclass.info and click incident response. And the main thing we're going to do today is Splunk. We'll move on to other things later, but this is the first and most important activity. Now, what happened here is Splunk paid some of their engineers to go onto Amazon, rent half a dozen servers, build a whole company with like a web server and other servers, and then attack it using various attack tools, record all that data, and publish it openly. And they ran a competition, which I participated in. That's how I learned about this. And I did well in the competition. And then after they were done, they open sourced the product. So I made my own server. I got 2 servers that have Splunk running, and they have the data already installed on the server, and you can just use it. And all I did was write my own scoring engine to record the right answers. And this is based on a Splunk capture the flag they ran about 8 years ago. So you go to boss of the SOC, and this is threat hunting with Splunk. And this might be going, yeah, these flags are going to the wrong place. I'll take those off. You should use these ones. I was just telling a student that started, I mean, these scoreboards point to the right place. This points to another one that you do not intend to use for this class. Anyway, so now let's play with it. There's a Splunk and splunk2.samsclass.info. I had to put a username and password in front of it because it started getting hacked by automated attacks. So the username is student1 and the password is student1. It's not a very secure security measure, but it's enough to stop the automated attacks from constantly trashing my server. And here you see Splunk. And Splunk has various fancy features, but the only thing we're going to use is the search and reporting. All Splunk is Google for log data. You install on every firewall, every server, and everything you have, you put an agent on there that harvests the log data and sends it to a central location. I see Karen's joined us. Morning, Karen. And then you can analyze it here, and you can just search through the log data here to see what's been happening on your network. And as you'll see, it has various techniques to try to help you do that. So you see it has about 1 million events here. And if you go to data summary, you can see what kind of data there is on this Splunk server. And the easiest thing to understand is the source types. There's some Windows event logs. These are just Microsoft's default event logs. They've all been forwarded to a central repository. There's Windows registry events. There is Sysmon. Sysmon, by the way, is a wonderful Microsoft tool from sysinternals. It's an extra thing you can install on your Windows machines. And what it does, if you've done Windows tech support like I have, you'll discover that like opening a folder and opening a file creates what seems like 50 or 100 events in the event log. And they're extremely opaque and hard to understand, like permission inspected for folder. You're allowed to open the folder. This user opened the folder. What Sysmon does is it has only about 10 types of events, and they are very simple, easy to understand events, like a process was launched, a process was terminated, a service was launched, a registry key was changed, a file was created. And so it just has nice, simple, clearly understandable log entries like that that are much more useful. And it adds useful extra data to them, like if a file is launched, it gives you the MD5 hash of that file because you're probably going to want to check to see if it's known malware. So that's what Sysmon is. It is a super enhanced Windows logging utility, which everybody should be running on all their servers. Then there's FortiGate. There's a FortiGate firewall in the network, and it sends some FortiGate logs up. There's a Windows web server, Internet Information Service, and its logs are up here. I'm not quite sure what the deal is with this Nessus thing. Then they have some mail logs. And then we have some stream logs. Splunk is monitoring the network traffic like Wireshark, and it's storing summaries of the network conversations. It does not store every packet, but it stores a summary, like you connected to this location and sent this data for HTTP, DNS, and other protocols. And then Suricata. Suricata is an open source intrusion detection system, so it is like an antivirus for the network. It scans the network traffic for known attacks, and it sends out alerts and such. And all this stuff is sent to the Splunk database. So there's one place you can search through it all. And you search here. So you can find things by looking in here. There's the type of data. So let me go back to my instructions here. Now, in professional real deployments. You have a big complicated network and you separate your Splunk data into different groups with an index. All the data that matters to us here is the index of bots v1, which is just boss of the SOC version 1. And all right, so they would like you to search this restricted data. Now, if you search, you are going to find 0 events because by default, Splunk only looks through the last 24 hours. And all this data is like 8 years old. So you have to use all time. Once you use all time, you will find a lot of data. It's going to find 1 million events. Now, that's going to take time. One thing that is not obvious is the speed of a Splunk search is determined by how many results you find. So if you want to get an overview, you can turn on event sampling and only look at, say, 1% of them, 1 in 100. That'll make the search 100 times faster, or at least a lot faster. And you'll only see 1% of the results. This number is going to be going up as it finds more and more results. And when it's done, it'll have a green check mark there to tell you it's done. It's also filling in a timeline of the events here. Okay, now it's done. So I found 9,000 events because there really are 900,000 events, and I'm only looking at 1% of them. Now, one way to use Splunk, which is not the best way, but it's the simplest, just like as you know, if you use Wireshark, you can look at the packets one by one. And you can do this with Splunk. Here are the log events one by one. So here's something from the Windows security log. Here's something from a Microsoft. Here's a Sysmon event, as I was just talking about. And here's other events. You can look at the log and read through them one by one this way, and that's pretty measurable. You can also expand them, and it'll show out the fields individually in meaningful fields like audit success, a message. Let's try this Sysmon one and see what it looks like. Whoops, got to expand the second. Well, there we are. All right, so here's Sysmon. And here I remember it has hashes, SHA-1, MD5, and other hashes. Here's the image. This is Splunk PowerShell.exe being launched, probably an internal Splunk process. Image loaded was a library, DIL, opcode. Here's the identifier of the process ID that was launched. There's hash values, time created. Like I say, this is an event that is full of useful information. A process was launched, you know what the executable was, you know what time it was launched, and things like that. So it's, like I say, that's much handier than a Windows event log. So that's one way to use Splunk, is look at these things one by one. But of course, we're going to use much better techniques than that to dig through 1 million events. So we've seen the source types. Okay, now I want to look at stream HTTP. And one easy way to do that is to just go back to search and go to data summary and source types. Now I can see what kind of data is there. And if I want to see one of these source types, I can just click it. Now you can control it by typing in the right text in the search box like Google, but of course it's easier if you just click rather than type, then it gets the format right. So this is source type equals stream HTTP. Now again, I'm back to 0 events because it's back to the last 24 hours. So I got to change it to all time. And now I'll see all the web traffic in this data. All right. And if I look at this web traffic, I can notice something. If you look at this, here is the content it sent, some kind of unprintable stuff containing Microsoft. Here's an HTTP. If I scroll down here, I'll find the request. Here's the request. This is getting some code signing certificate recovery list, part of making an HTTPS connection or something. Nothing too exciting. Scroll down a bit further, look at a few more of these. Shouldn't have to look too far before I see something suspicious. This is getting a product for hardware compatibility. All right. Now, one thing that's happening here, I'm seeing all the web traffic on the network. But what I'd really like to do is see the web traffic coming to the company's web server to see what's happening at the web server. And for that, I put in the domain name of the web server. And the domain name of the web server here is imreallynotbatman.com. They made a theme for this thing, and they made a company based on like the Batman movie. So you'll see those characters and those names used in the data here. So if I add this to the search, I've got a type of data. You can just put a word here, and just like Google, it will just find events that contain that word anywhere. The Splunk purists don't like doing things this way because it's less efficient. It uses more computer cycles, but it's an easy way to understand and get the raw job done. They prefer field type equals value. That's more efficient, but this works. You can just search for a word. This is like the old-fashioned grep search. Before there were tools like Splunk, you would just put all your log data in a text file and use grep to find words. And that's what this is going to do. But the point is, it's going to find web requests that contain the domain name of the company server. So those are only going to be requests coming to the company server. That domain name wouldn't be anywhere else. And so now here they come, thousands of them. But if you look at these, here it tells you some document has moved. Notice the very first one here. It's doing a search, going to some search, and the search word is select 0 from sleep, select from sleep. This is a SQL injection attempt. This is not legitimate traffic. And almost all the requests to the web server are this way because the attackers used a vulnerability scanner and ran it on the web server. And vulnerability scanners just have a library of hundreds of attacks, and they just try every attack one after another. So this is a SQL injection sent to the web server. And most of them will actually show you the name of the attacker. Let's see if I can find one like that. Yep, here's another one. This is sending another search, and you can see right here, Acunetics product, Acunetics scanning agreement. What they did was they took a commercial vulnerability scanner, the Acunetics scanner, and they just used it without modifying it. This is what a really low-level sloppy attacker would do. These header fields are added to the requests from the Acunetics phone scanner to warn your product team that this is not a real attack, it's a scanner, and a more professional hacking group would have at least stripped out these headers. But anyway, now you can answer a whole series of questions, and you'll find them here. There are questions to answer. So the first one is, what is the name of the scanner? Well, that's Acunetics. You can see it there. Then you want the attacker's IP address and the web server's IP address. Well, the attacker's IP address will be the source of this, and that web server will be the destination. So here's the source IP. So this number starting with 40, that's the attacker's IP address. And the destination here, destination IP, that's going to be the web server's address. And I'm going to copy that and keep that around in a text file. I'm going to need it again later. This is the web server. All right. And because the next part is going to be more interesting. Now I want the defacement file name. Now this is where you begin to see the real power of Splunk. We are going to find 8 malicious log entries out of those 1 million. And you're going to see how easy it is. Because here's a simple question. If you have a network with proper network traffic control, your server can only be a server and never a client. This is real important. So here's a question. Did the web server make any outgoing web requests to download data directly on the web server? Like somebody opened a browser on the server and downloaded something, because that should never happen, and that should not even be allowed by your traffic control rules. And we can answer that question now that we have the server's IP address here, because here we have web requests. Well, I'd like to filter these web requests by the IP source. So if you go here on the left, you can see the names of fields. And if I click on something like client IP, I'll see values. And if I click on one of these values, it will fill it in up here. Now it's only going to show me packets or log entries where the client IP is that. So I'm finding traffic. This is traffic that came from the attacker, and there's a lot of that. But what I want is traffic that came from the web server itself. So I paste in the web server's IP address here. All right. So this would be a request originating from the web server, which should never happen. And I get 0 events. So I might think I'm okay, but remember, I left the domain name of the web server in here. And of course, if it made an outgoing request, it wouldn't be going to that domain name. It would be going somewhere else, to Yahoo or something. So I have to remove this from the query to find the packets that are going backwards through the network. And now I'm getting traffic that's going backwards through the network, where the web server is acting as a client. And that did happen a few times. Here's the first event. And when this query is done. I think there'll be 8 or 9 of them. And these are suspicious events, things that shouldn't happen where traffic is flowing backwards, 9 of them. And if you look down here at these events, this junk is a binary file being transferred down to the server. So somebody moved a binary file. And if you scroll down below here, you'll see the actual request that caused it. And here's the GET request. So this is somebody requesting a file named Poison Ivy is Coming for You Batman.jpg. That is the malicious file used to deface the web server. And they got it from this IP address starting with 23. So this is another one of the attacker's staging servers. The attacker had an IP address starting with 40 that was running the vuln scanner. And they apparently also have control of this server, which is hosting malicious files to download. And they were somehow able to gain control of our web server and cause it to make an outgoing HTTP request. We've not yet figured out how that happened, but here we have them downloading an image that's going to deface the server. And they didn't connect to it just by domain name. They connected to it by a URL. And here it is, prankglassinebracket.jumpingcrab.com:1337, which is another typical hacker trick. Instead of hosting their web page on port 80 or port 443, they commonly use 1337, which is leet speak for leet. So this is clearly a malicious server. And now we have, again, a whole bunch more flags you can find here. You get the name of the file name, the name of the domain name of the attacker's staging server, and the IP address of the staging server. And so that's the first bunch of flags, how you find them. And there's more coming, but I think that's enough to get you started. So try finding some of them with Splunk and let me know how it goes. And as usual, there's a scoring engine. I use the one back here on the instant response page or the main page here. And I'm going to update the one on the actual Boss of the Sock page or just take it off so you don't send your stuff to the wrong scoring engine. Give it a shot. I'm going to stop this recording.